Hi everyone. Let's begin a new concept of statistical analysis. It's very important analysis of in the marketing, right? And in the various areas. Discriminant analysis. Discriminant analysis means basically we had already used regression analysis, but regression analysis we are using when our dependent variable and independent variables both are metric data. But if our dependent variable is not a metric data, that is on the categorical, so we will use discriminant analysis, right? Here is to classify basically discriminant analysis, where is the two kinds of groups, right? Whether, let's say an example, students are successful or not successful. So we can categorize whole data into two parts. Then we have to use discriminant analysis. Let's say successful candidates, we are giving one number, and for unsuccessful we are giving two number. So here is this data is dependent variable, means that is categorical, and it depends upon number of variables. Might be possible it depends upon the whatever the test marks they had scored, or they had given interview, what marks they had scored. So I mean it depends upon the number of independent variables. So we can classify into two or more groups, right? That means it is a categorical variable. Then the discriminant analysis, it's a similar to regression analysis, is used to assess the relationship between dependent variable and independent variables, right? But the only thing I had already said, discriminant analysis, the dependent variable is categorical and non-metric. It's a non-metric, it's a dependent variable, correct? It's a dependent variable. So this is it's a like a regression equation, right? It's a regression equation, y equal to a plus b1, x1, b2, x2, b3, x3, and so on, right? This is known as, where is that one is the regression function. This is the discriminant function. This is known as discriminant function. Y is dependent variable, or we can call it grouping variable. Why grouping variable? Because it can categorize into two groups, right? X1, X2, X3, these are independent variables, and we can also call predictor variables, because they are the predictor. They will predict the dependent variable. Dependent variable means Y, right? Here is we are using term unstandardized coefficients also can be used in the equation as coefficients of the different IVs along with the constant term to predict the value of the DV. This is the constant term. A is our constant term. We will get these values through our analysis, and we will put all these values here, right? And then we could be able to calculate, right, dependent variable status. The standard coefficient beta is, however, measured in the standard deviation. Here is the interpretation. First of all, we must understand what we are going to interpret, and I would correlate with my example also, definitely. Interpretation means here is we are talking about this thing, low value of its lambda reflects high significance. Is the as low as value of the Wilks lambda, that means it shows high significance, right? And the F test should show a p value should be less than 0.05, and larger the absolute value of the standardized coefficient, better the predictive power of the variable. These are the some interpretation on the basis of which we will interpret our model. Let's begin our example. Then one by one, I will prove with all these three interpretations with my result. Here is, you could see here example one. I have taken total 50 respondents, 50 candidates data. Might be possible they had given this entrance exam, right? On the basis these three tests, test one, test two, and interview, it would be decided as whether they have qualified this exam, or they have not qualified, they are disqualified this exam. So status is, I had already marked as 2, 1. 1 stands for qualified, 2 stands for not qualified, right? So this data, what we have to do, we will enter in our SPSS file. You could see here status, right? Status is I have already defined 1 for qualified, 2 for not qualified, right? And this is the nominal data, just a number we had assigned. Test 1, this one is the first we had, you can say pre-test, or this one we can say mains, then interview, like in IS examination. This one is the first is the pre-examination, then the mains, then interview, followed by the interview. So in that way, test 1, test 2, and interview, again, this is a metric data because there's the numbers we had assigned, and that is on the, we will measure on the at the scale level. So data view, when we have to go for this, you can see here, all this data I had copied from my Word document, right? All this 30 respondents data is here, right? Those were appeared for this exam. So this one is the first column, shows the status, test 1. That means it could be a pre-exam. Test 2 might be post. This one is the mains exam. Then after that, those ever, I mean, that one is the interview also. On the basis of which there's the status, whether they have qualified or not qualified. So discriminant analysis, we would analyze this thing. How we have to analyze? First, we have to click on analyze. We will go to classify. In this classify, 1, 2, 3, 4, fifth option, discriminant. We will click here, right? Discriminant, right? मैं इसको reset कर देती हूँ. Here is status. Status means it is a grouping variable because we want to group them whether they have qualified or not qualified. So we had already defined there in my SPSS file. 1 means 1 is the minimum value, 2 is maximum value, 1 means qualified, 2 means not qualified, right? We have defined here all these categorical variables, test 1, test 2, interview, we can shift it. These are my independent variable. This is the dependent variable, or we can call it grouping variable, right? In regression, we are not calling it grouping variable, right? This is the dependent variable, or we can call it indiscriminate and a grouping variable because it is categorizing into 2 parts, in 2 groups. And these are my independent variables, right? Statistics, yes, we have to click on unstandardized, right? Coefficients we require. Then classify, right? Yes, summary table we require, leave 1 out classification and replace missing value. If let's say I have missed any value in my table, right? It could be replaced this missing value with the mean. Matlab, I mean rest of the values ka, it will calculate mean, and after that it would replace it with the mean value. Then we will continue. Then we will press OK. Right. This is my output file. You could see here, this is my analysis case processing summary, group statistics, summary of canonical discriminant functions, weak slender. Here is standardized canonical discriminant function coefficient, structure matrix. This one is the structure. This one is the structure matrix, right? Standardized canonical function. Then the canonical discriminant function coefficient, function of a group centroids, and the classification statistics. When we talk about the classification processing summary is here, and prior probabilities for groups, and last one is classification results. So all this data I will copy in my Word document. There would be the bigger size, and I could be able to explain more with more clarity, right? Output table, right? This is my first table that is already reflected in my, you could see here in my output file. This is my, this one is the analysis case processing summary. So in this here, you could see here valid 30 is my number, no missing value, 0 missing value. So that means total is the 100%. Means it is analyzing all 30 cases and is the 100% result. Then the group statistics, you could see here group statistics. That was the second table I had copied here, right? Group statistics. You could see here status is qualified, not qualified, right? In test 1, 23, test 2, 23, and interview 23, right? The weighted is 23. Not qualified, 7 candidates are not qualified, right? 7 candidates are not qualified. So this is the 7, and total is 30, right? I mean 100%. Then we come to the summary of, right, eigenvalue की अब हम बात करते हैं, right? This is my eigenvalue. right? Eigenvalue and canonical correlation. Canonical correlation is good, 0.739, right? It should be closer to 1, right? That is the strong correlation. And eigenvalue, it should be and 1.203, it should be greater than 1. Then Wix lambda, right? I had already copied this data also from my output file. Here is, you could see here, this is the eigenvalue table, this is the Wix lambda file, Wix lambda table, and you could see an interpretation. Now we come to, it is significant. It shows it is significant. There would be the high value of the Wix lambda, this value between 0 to 1. It should be exist. This one is this value. It should be fall into between 0 to 1. And near to 0 means shows this one is the between the means the less discriminating power of model. Agar shows this one is the right. And यहाँ हम बात करते हैं, in this model 0.454 is indicating the model is good because its value should be closer to 0. It reflects the better discriminating power of the model, right? If there is the right, and it is the probability value of the F test shows discrimination between the groups is highly significant. P is less than 0.05 at the 3 degree of freedom. Correct? 3 degree of freedom. If there would be the high value of the Wix lambda, right, that means it shows low significance, means less discriminating power of model. But when it is the more closer to 0, right, it is low value, that shows the model is good. More value closer to 0, that means better discriminating power of the model. So you understand what is the meaning of this. If it would be, might be possible 0.7 something, so that means your model is not good, right? Your model is less discriminating power of model, right? Then we come to the standardized canonical discriminating function coefficient. It's a very, very important table. Again, I have copied from this place, right? Standardized canonical discriminant function coefficients. Now, how we have to interpret this table? You could see here, test 1 is, right, 0.599, right? Highly, test 1 is the most explanatory power with coefficient of 0.599, and test 2 has the least explanatory power with coefficient of 0.475 for this result, right? And this one is the at the second place interview, right? And test 2 is at the least, this one is the least explanatory power to explain this model. So highest is test 1, 0.599, and interviews 0.74 at the second place, and last one is the 0.475. So we have to interpret this table in that way. Then we come to the structure matrix. Structure matrix, both these things are similar to each other. Structure matrix, right? When we come to the structure matrix, that is also again standardized canonical discriminant function, right? So output shows that was the same thing, right? The best predictor with the coefficient 0.736 followed by, this one is the best predictor, and followed by the interview. This one is the 0.75, the next to this, and least, that one is the last one, the coefficient, that is the least predictor, right? That one is the very weak predictor to this model. Then we come to the canonical discriminant function. Test 1 is, you could see here, right, 0.091, 0.051, and 0.0. This is it is a similar to unstandardized. It's written here unstandardized coefficients. Like in regression, we are using all these values in our to calculate this equation. Yeah, isko hum bolte hain. What we are calling it? Discriminant function. What we are calling it? Discriminant function. Right, this equation. So here is the, what is the value of A? This is the value of A. This is the value of A, right? So what we have to do, value of A, right? This is the value of A, right? A means constant. This is, sorry, small a. That is already reflected in our table, right? This is the value of A. So we had put this value minus 11.199 in my equation. Then after that, test 1, right? After this, test 1. Then test 1 coefficient is 0.09. We will put here test 2 coefficient is 0.05 and we have to put here an interview 0.077 interview. Up now, suppose we want to, some new candidate has come, right? Whether he is successful or not successful, right? So we will simply put all these values here and then we have to calculate this Y value. Y provides discriminant score of any function whose test 1, test 2 and interview scores are known. If we know test 1 of this particular candidate, test 1 marks, test 2 marks and interview marks, then simply we will put this thing in this in our equation and we can calculate our dependent variable, right? Why we have to calculate, and then we can decide whether he's falling, whether he has qualified this exam or he has not qualified this exam. Then functions as group centroid. Yes, this of course, this is also a very, very important table. Qualified and not qualified, right? This is the status. This table, function and group centroid, shows the unstandardized canonical discriminant functions evaluated at group means. So here is, we would understand like this, 0.585, right? This is the mean of qualified. And this one is the mean of not qualified, right? If person is falling towards this side, so that means he or she has not qualified. But the person is falling towards this side, right? So that means he or she has qualified, right? So classification of the processing summary, when we talk about, right, again that was the same 30, right? This one is the prior probabilities for the groups. Yes, we will come on this classification result. That's the most important part. I will show you this part. This is the classification results, right? So what we are interpreting here, we are interpreting 90%, right? We could see here, this one is the 90% of original group cases correctly classified, right? This is the output of this. I will show you in my SPSS output. This table I have taken from this place. Yeah, this one is, and you could see here everything is written in 90% of original group cases correctly classified. B point, cross validation is done only for those cases in the analysis. In cross validation, each case is classified by the function derived from all cases other than that cases, and 86.7% of cross validated groups case correctly classified, right? So we would see here, the table reflects the model classifies correctly. It is closer to 100 means model is better. Underline this statement, right? It is closer to 100. It means it shows model is better. And our model is 90%, right? Original group cases, that is correctly classified, right? So here is, we could see here, as per above table, 90% of the original group 30 cases are correctly classified. Classification matrix is also called confusion matrix. Also, somewhere is the people are using term confusion matrix, and model is good or bad, right? Through this only we could decide whether our model is good or bad. This is the table. This is the decision maker classification result, whether our model is good or bad. Statistic significance by Wix lambda and the probability value of the F test, right? F test value, right? That should be significant, right? It should be less than 0.05. And Wix lambda, it should be closer to 0 towards the 0. That means it is, I had already defined here. You could see here, right? High value of Wix lambda, it shows low, it shows less discriminating power of model, correct? But when this one is it's near to closer to 0, that reflects better discriminating power of the model, correct? And I'm sure you understand. And this one is the statistical significance, and better predictor and poor predictor standardized coefficient. Which factor, which particular factor is a good predictor, better predictor, and which one is the poor predictor? I had already explained here. Here is all three values are here. Test 1 is the best predictor because highest coefficient value, right? Then followed by the interview with the coefficient value is this. And the least predictor, test 2, is the last one, is the least predictor in this, all out of these three predictors. When we come to the where we are going to use this discriminant analysis, for example, somebody had applied in your bank loan. This one is the credit card, so that this person is on the low risk or high risk. You can decide easily by this discriminant analysis. Discriminant analysis can be useful, I mean, through a number of the cases. You can decide on the basis of this, predict discrimination between buyers or non-buyers, heavy users or light users in your mall or in your shop. You would like to know this thing. And the most important thing in this discriminant model is it gives an unbiased decision model. It will give you transparent picture, right? um, I mean, you have to take decision making, but when you are going to apply, this is the replacement of the regression model. But regression model is applied when your dependent and independent variables, both the variables are your metric. But when your dependent variable is not metric, it is a categorical, whether it is divided into two groups, 1 or 2, 0 to 1, right, or any group. So then you are going to use discriminant analysis, right? And but your independent variables are metric, right? So simply and that is why we are calling it discriminant function. So I'm sure easily now you could be able to distinguish between regression analysis and discriminant analysis, and I'm sure that would be helpful in your research work. And you have to go for some more examples. I would upload some more examples on my YouTube channel. Thank you so much. Thanks a lot for watching this video. Thanks a lot.